Hello everyone. In today's session, we are going to talk about another toy problem. So already we have discussed about a few toy problems like egg puzzle, monkey and banana problem. So along with that, today we will focus on one of the famous example, the missionary and the cannibal problem. So by the end of this session, you will understand how AI formalizes a problem as a state space. So, what are the constraints, the operators, and the goal states of the missionary and cannibal problem? So, we can see this step by step. So, before going in and discussing about the missionary and cannibal problem, let us have a glimpse about the toy problem and the real world problem. So, the toy problems are intentionally developed to illustrate or exercise the problem solving methods. So, it doesn't have a closer look towards the real world problems because they give a very concise and exact description of what exactly the problem is about. So when you talk about the real world problems are the one people really bother about. So they wish those problems should be solved. So examples are route planning, medical diagnosis, gameplay, robotics. So all these are real world problems. So these real world problems generally have lot of ambiguities and uncertainties. So they do not have a single agreed upon descriptions because different people define the problem in different ways. So the boundaries are not fixed. So we start with the toy problem because they are clean. You practice in the toy problem and then you go and apply it in the real world so that you will get an optimal solution. Now let us look at the characteristics of the toy problem. The toy problems are not real world problems. They are generated for research and educational purposes, also for fun. Secondly, they are generally played on a board or a paper. So, meaning the environment is physical and it is bounded. For example, you can take a chessboard, a tic-tac-toe problem, a snake and ladder problem. So, whatever it is, they are played over a board. And the environment is controlled. We know every rule, what happens next. So, there is no hidden information. So, that's what make them ideal for algorithm design. Fourth, problem formulation is possible because we know that the boundary conditions and the constraints already. So lastly, these toy problems can be converted into computer programs. So some of the examples we have seen, like it's the tic-tac-toe problem, the monkey and banana problem, eight puzzle problem, any problem, any so many toy problems we have discussed. So each of these has been used extensively to develop and test AI search algorithms. Today we will mostly talk about the missionary and cannibal problem to begin with. Now, so what is the main objective? So this is a classical river crossing puzzle. Generally, it is used in a very introductory AI course to understand the scenario. Now, we will see the problem description. Here we have three missionaries and three cannibals on the left bank of the river. Now they all need to get to the right bank of the river. Okay. So they have only one boat. The boat can carry at most two people at a time. And critically, the boat cannot cross empty. Someone has to row the boat always. So what is the constraint? If at any point the cannibal outnumber the missionary on either bank or in the boat, the missionaries will be eaten. That's an interesting path. Cannibals must never outnumber the missionaries on either side of the river. Keep this point in the mind. So this applies to anywhere like left bank, right bank. Okay. So it must be very careful. So what is the goal of this problem? Finding a crossing sequence that gets everyone in the sense all six people, three missionary and three cannibal, safely to the right bank. So this is the goal of the problem. Now we will see step by step of how to achieve this. Now, what is the initial state or initial setup? So we know that we have three missionaries, so we're calling them as MMM, and three cannibals, we call them as CCC. Now all are on the left bank. Missionaries and the cannibals are on the left bank. The boat is also there. So what is our destination? Must reach the right bank safely, must reach the right bank safely. All to cross from left bank to the right bank, you have to use the boat. Okay, now think for a moment. How would you move all these people to the right bank? Remember one thing, you can't send two cannibals to other side if the missionaries are outnumbering, means they'll be eaten. And also you need someone to bring back the boat. The boat has to be rowed by at least one person. It can be a missionary or a cannibal. Now, the important point, the kind of reasoning an AI agent must perform systematically and exhaustively is very, very important. Before we formalize the solution, why we call this an important problem in AI? It's not just a puzzle. So it's a small miniature of the real world problem with a lot of constraint. You have to do a lot of decision making based on the constraints. So the kind of problem that showed up in logistics, scheduling, and safety critical systems. So these are the problems. So here there are four things that you have to consider. State space search. What is a state space search? Already we have discussed. It's a configuration of the solutions. Okay. Every configuration of people is a state. Means how we are arranging the missionaries and the cannibals. It's a state. So based on the arrangement, the searching process happens to find the valid path. What is the constraint satisfaction here? Multiple states might be illegal. The solver must respect the constraints while navigating towards the goal. So we have to filter out those illegal constraints. You know what are the legal constraints? Like already we said, there should be at least one person to row the boat. Outnumbering should not happen because the cannibals might eat. So it's very careful about this. What is goal directed reasoning? We start at a known state and aim for the specific goal. Means clear start. All six on the left side of the black, missionaries and the cannibals. What is a clear goal? All six should be on the right side of the bank. So you have to find a path, correct sequence of traversal from left bank to the right bank. So when you will go for backtracking, some paths lead to the dead ends. So then you have to go backtrack and find an alternative path. It's very important. Okay. Now we will talk about the formal problem definition. Okay. So every arrangement of the missionaries on the left and cannibals on the left on that is both banks, along with the boat position is a state. The AI searches through the state space like navigating a map to find the valley path from start to goal. What is the start? All are in the left bank. You have to move everybody to the right bank. Okay. Now, if you see the initial state, suppose you write all three missionaries on the left, all three cannibals are on the left, boat is also on the left. This is where we begin. Okay. So what is our goal state? Goal state is zero missionaries on the left, zero missionary cannibals on the left, boat is also on the right. So all 6 people plus the boat is on the right bank. Everyone has crossed. Okay. Here, this M represents the missionaries, cannibals, and the bank. If I have one here, means in B, if I have one. So what does it mean? If B is 1, then we say the boat is on the left bank. If I have 0, the boat is on the right bank. Okay. That's what we have written. 3, 3, 1. 1 means left bank, 0 means right bank. Okay. So what are the operators involved? Right. Here we can move 1 or 2 people across the river in the boat. Okay. That gives us 5 possible loads. They are 1 missionary, 2 missionary, 1 cannibal, 2 cannibals, or you can take 1 missionary plus 1 cannibal. So we will talk about all these details in shortly, how all these are happening. Now the point I want to register here is we will be talking about the state MCB, missionary cannibal on the boat. When it is numbered 1, means the boat is in the left bank. When it is numbered 0, the boat is on the right bank. These 3 represents the ranges 0 to 3. 0 to 3. Okay, right. So we will continue this, right? The state representations and the safety rule we will talk about. Okay, right. Now, already we talked about what is M, what is C, what is B. Same thing. M is the missionaries on the left bank. So everything we have to start only from the left bank. Cannibals on the right bank. Boat is, I'm sorry, cannibals on the left bank. Boat is also on the left bank. When the boat position is 1 and 0 changes, 1 is left, 0 is right. So right bank counts are derived. Okay. And total possible states are 4 into 4 into 2, that is equal to 32. Okay. So there are 4 values. That's what it is for. M can be 0, 1. What is the value of M? It can be 0, 1, 2, and 3. Similarly, C also. B can take either 1 or 0. So total state space is 4 into 4 into 2. That's 32 states. So out of this, Only 16 states are valid, safe and reachable. The other 16 are illegal because in those states, cannibals outnumber missionaries somewhere. It's a very important point. Okay. Now, we'll talk about the safety rule. So, what is a safety rule? When we call a particular state is safe on either of the bank, if there are zero missionaries on that particular bank, meaning no missionaries to be eaten, or the number of missionaries is greater than or equal to the cannibal on that particular bank, then the bank is safe. If the missionaries are present and they're outnumbering anywhere, then that particular state is immediately discarded. They are illegal because they'll be eaten. So this is the constraint satisfaction in action. We are pruning the search space before we begin searching. Okay. Now, we will talk about the table about the valid states. Okay. And also the boat operators. We have different states, and then we have the left bank with the missionary, left bank with cannibal, right bank with missionary, right bank with cannibal, and then both side, and then the remand. Now, we'll start with the first one, this one. Okay. So, our state 1 is 331. Missionary is 3, cannibal is 3, and boat is 1. So, the left bank has 3 missionaries, 3 cannibals. Right bank has 0 missionaries, 0 cannibals, and the boat is on the left side. So this is our start state. So what is our second state? Likewise, we'll go through a few states. When it is a second state, if you see the second state, you have to begin. So there are 3 missionaries, 2 cannibals, and boat is 1. Meaning, on the left bank, you have 3 missionaries, and you have 2 cannibals, and then 0 missionaries on the right bank. You can see here, you have moved 1 cannibal to the right hand side, right back. And this is a valid state. Likewise, the third state also. Now, when you talk about this fourth state, you have 111. 1 missionary and 1 cannibal on the left, 2 missionaries and 2 cannibals on the right, boat is on the left, is the state. Question mark. So, what we have to check here? Here, 1 missionary on the left side, 1 missionary is greater than or equal to 1 cannibal, no problem. On the right, 2 missionary is greater than or equal to 2. So it is a safe state. It's valid. Okay. Similarly, I want to focus on the few things. Similarly, you can keep going like this, right? Likewise, if you go to the fifth state, here missionaries are more, cannibals are left. So it's valid only. Here also, the missionaries are greater than the cannibals. Here, the missionaries and cannibals are equal in seventh state. Here also it's equal. Here it is equal. Here it is greater than or equal. Here, okay. So likewise, if you come to the 16th step, on the left side, okay, Nobody's left. No missionary, no cannibal, no boat. 0. On the right side, you have 3 missionaries, 3 cannibals, and the boat is on the right. So that is a valid goal state. Right? Supposing if I have a state of 2 missionaries, 3 cannibals, might be right, 2 missionaries, 3 cannibals, 1. Okay. This is all on the left back. Suppose if I have this particular state on the left back, 2 missionaries, 3 cannibals. So now the cannibal is outnumbering the missionaries. Okay. The state is illegal. Okay. So this is not safe. This is not even in the table. Okay. Right. So I think you can go through this one by one. So always the cannibals should be less than the missionaries. Otherwise, they'll eat it. Now we'll talk about the boat operators. So how to do this? Each move sends 1 or 2 people across the river. So the boat directions are left to right or right to left and so on. All the 5 operators can be applied in both directions. So what is one? First one, send 1. So send 1 missionary, that is move 1 m across. Okay. Status m changes to m changes by plus or minus 1. C is unchanged. The boat flips. In operator 2, send 2 missionaries. Just move 2 missionaries across. Now m changes by plus or minus 2. C is unchanged. Cannibal, that is. Again B flips, boat flips. So in the third operator, you're going to send 1 cannibal. Already I've sent 2 missionaries. Okay, we're going to send 1 cannibal. M is unchanged. C is changed to plus or minus 1 and the boat flips. Now I'm sending 2 cannibals. M is unchanged. 2 cannibals crosses, so it's C plus or minus 2 and the boat flips. Now send 1 missionary and 1 cannibal. So both M and C are changed to plus or minus 1 and the boat is flipped. So the plus or minus here depends on the direction of the boat. If the boat is on the left going to right, okay, people leave the left back. The boat is on the right and going to the left, people return to the left back. Okay. For example, suppose if I have a state of 3, 3, 1, 3 missionaries, 3 cannibals, and 1 boat. And fourth operator is applied. Fourth operator is this one. So you are sending 2 cannibals from left to right. Okay. So what is the value of C now? C becomes 3 minus 2, that is equal to 1 on your left bank, because missionaries, cannibals. You are sending 2 cannibals, okay, from the left bank to the right bank. So your value will become 1 over here. Boat flips to 0. So the new state, what is the new state from here? 3. This will become 1 and the boat value will become 0. It has moved. So the left has 3, 1 cannibal. The right has 0 missionaries and 2 cannibals. We'll go from this side. Here nothing is there. 2 cannibals you have crossed that side. So this is a valley. There is nobody to eat here. I hope you understand this, right? Right. Now we will talk about the production rules, the formal if-then rules that govern every move. Okay. After applying an operator, check both banks like we did in the last exam. If missionaries are outnumbered anywhere, if you're having cannibal more number, then discard that particular. Okay. Now, let's take the constraint one. The resulting state must be safe. After applying an operator, check both banks. If the missionaries are outnumbered, then discard that particular. Secondly, the boat cannot travel empty. Okay. Constraint 2, I'm talking about the constraint 2. You must send at least one person in the boat. This is why we have 5 operators. Constraint 3, the boat holds at most 2 people. Okay. No operators sends 3 or more at a time. That's what we saw in the last thing. So talking about the production rules, we have almost 10 rules. So what is the rule number 1? One missionary sailing the boat from bank 1 to bank 2. One missionary sailing from bank 2 to bank 1. Here you have 2 missionaries sailing the boat from bank 1 to bank 2. Reverse here. 2 missionaries sailing the bank from bank 2 to bank 1. Talk about the rule 5, M and C. One missionary, one cannibal sailing from bank 1 to bank 2. Sixth, one missionary, one cannibal and one missionary sailing from bank 2 to bank 1. Here 2 cannibals are sailing from bank 1 to bank 2. Again 2 cannibals are sailing from bank 2 to bank 1. Here only cannibal is sailing from bank 1 to bank 2. Here it is bank 2 to bank. So sequence of execution to achieve the goal is very, very important. Try not to revisit the same states that has already been used so that and it might get stuck into an infinite. Now, we'll just talk about the constraints on the moves. So, the resulting state must not leave missionaries outnumbered by cannibal on either of the bank. The boat cannot travel empty. The boat's capacity is 2. These are the actual constraints. Right? Already I have discussed this. Try and apply the rule 4 from start state. So what we are trying to do here, our starting position is 331. Means what we are trying to do, apply rule 4. What is rule 4? What does rule 4 says? You are going to send 2 cannibals from left to right. Okay. But send 2 cannibals from left to right. So now how does my current state changes on the right bank? Okay, new state will be this side 3, 1 and 0. 3 missionaries one cannibal. This is on the left side. What happened on the right side? Two cannibals will go. So missionaries will be 0, two cannibals will be there. So this is a safe state value. So it's not outnumbered. Okay. Now we will see the next thing, the solution actually. So you can see here, you have the solution applied here. So you have 3, 3, 1. You're going to apply operator 4. Okay. So start state, 3 missionaries, 3 cannibals. Person in the bank, river 2 is 0. Board position is bank 1. That is on the left side. Now what happens? After application of rule number 5. Okay. 2 missionaries and 2 cannibals are here. 1 missionary and 1 cannibal is present in the back too. Okay. Might be I can write this side. I know here on the right back you have 1 missionary and 1 cannibal. After applying rule 2, what you try and do here? Again, you try and bring 2 missionaries, 2 cannibals. From here you bring this 1 missionary also here. So on your right side only 1 cannibal is there. Because if you are not leaving means cannibals might eat it. Now what you try and do? You keep already 1 cannibal is there. So take 2 cannibals from here. Now 3 cannibals, already 1 cannibal is there. Now 3 cannibals will be there. So when you're returning back, you bring 1 cannibal. Now you take 2 missionaries when you go this side. So here it will be CCMM. Okay. Now when you come back, you bring 1 missionary. So 3 missionaries will be this side. I mean 2 missionaries and 2 cannibals. Okay. Here it is. Already it's only 1 missionary, 1 cannibal. So you can bring 1 missionary and 1 cannibal again. So again it will be here only cannibal and missionary. Now you take 2 missionaries this side, leaving the 2 cannibal. So now all the missionaries are here. You take 1 cannibal from here. So it will be CCCMMM. So when you go from here again, you take 2 cannibals. And when you come back, you bring again 1 cannibal. When you go back, again you take 2 cannibals. Now this is your goal state. So these are the rules applied. Okay. Fine. Now I hope it's clear. The references are from Stuart Russell and Peter Norvig. So what we have discussed so far here is that we are trying to backtrack, make some moves, do some intelligent exploration, and try to find the illegal moves and avoid the illegal moves, that is the visitor states. Sometimes you have to make a temporary move that is away from your goal, but still, in order to reach the goal state, that's really important. Okay. So, already almost we have made, I think 11 moves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 to 12 moves we have made to solve the missionary and cannibal problem. So the AI systematically applied the operators, checking the constraints, doing the backtracking whenever needed. So we move the cannibals across whenever without affecting the missionaries. Okay. The first transfer was we try to move all the missionaries towards the right, and then we slowly move the cannonball to the right again. So that's a backtracking in the solution space. Thank you.